Hello guys, welcome back to In 5 Minutes. In this presentation we are going to see hazards and hazards covers particularly in the combinational circuits. So what do you mean by hazards? Hazards, there are some difficulties in the circuit due to the construction and the propagation delays of the logic gates. Now there are particularly two types of hazards are there. So let us start with the first one, which is nothing but the static one hazard. This type of hazard occurs when there is a condition y is equal to a plus a complement. Now we all know that this is a standard rule of Boolean theorems or the logic expression that a plus a bar should be always equal 1. That is nothing but it is also called as static 1. That's why it is called as static 1 hazard. Okay. Now what happens when the hazard happens when a makes transition from 1 to 0. So a, which is making a transitions from 1 to 0. Now initially a is 1, therefore a bar is 0, so 1 plus 0 is 1, that we all know that. But let us see how actually the circuit works. Now to implement a plus a bar, I have here a circuit gate. OR gate is connected in such a way that one of the input is a and the other input of the OR gate is inverted with the help of a NOT gate, and we obtain the output y here. Let us try to draw the timing diagram of this particular circuit to understand the static one hazard. So what we have here, this is the a, this is going to be the a bar, and the final output y, a plus a bar should be plotted at this point. This is the time axis, okay, and this is the amplitude or the voltage axis or the logic 1 logic 0 level, you can say. So as we all know that before the operation of static hazard, a is 1, so I am writing this for a changes or transition of a from 1 to 0, means what initially a is 1, so I will draw a1 here. So initially for first clock cycle, this is the first clock cycle or first interval, and this is the second clock interval. So for initially a was 1, definitely if a is 1, a bar is going to be 0 and y is going to be 1, because 1 plus 0 is 1. Okay, so it is 1 0 and it is also 1. Now what happens, a makes transitions from 1 to 0. So if a suddenly change from 1 to 0, what happens, for a very short period of time there is a propagation delay in NOT gate to produce a bar from a. Okay, so it will take time for a bar to be produced as 1. So what will happen here, for a very short duration of it will remain 0, and after that it will be 1. Okay, means for a very short duration of time here, for this one, input to the OR gate is 0 0, and we all know that 0 plus 0 is 0. So what output I got here is 0, and after that it will go to 1 and it will remain 1 for the rest of the cycle. That is nothing but the combination 0 1, 0 plus 1 is 1. Okay, now this happens just because of the delay time of this NOT gate, time taken to produce a bar while a changes from 1 to 0. For a very short duration of time it has got output 0 here. So this time period is in the order of nanoseconds, so I'll put here in the order of somewhat approximately equals to nanoseconds. Okay, and this time period for a very short duration of it is giving me 0 output, that is called as glitch. Now there is a problem of glitch in the combination circuit, as you are seeing in this is a static one hazard. Now this problem of glitch or the 0 for in nanosecond order, for combinational circuits it may go unnoticed because it is a nanosecond time. Okay, but in sequential circuit, more particularly in asynchronous sequential circuit or the asynchronous counter, it may cause a major malfunctioning. This topic is more discussed in the sessions of asynchronous counter, or particularly mod n or modulo n or divide by n counter within 5 minutes. So if you want to know more about glitch, then you can stay tuned to in 5 minutes in that session. So this is all about the static 1 hazard. Okay, for very brief period of time it is showing some glitch or the zero output, particularly in the OR gate.